What if you could build a truck that sets new standards for fleet efficiency by moving more goods with less fuel to reduce carbon emissions? Shell's Starship 2.0. The future is here. On the road, North Carolina. Starship 2.0, one of the world's most advanced trucks, is undergoing a series of tests. The aim is to find ways to maximize the efficiency of transporting goods by road, improve fuel efficiency, and reduce CO2 emissions. Ryan Manthiri is the project leader for the team from Shell that created Starship.
Currently, the on-highway freight transport industry accounts for around 9% of global CO2 emissions. That has to come down. Solutions like Starship help move us closer to meeting that challenge.
To achieve that goal, the team brought together readily available technology and combined them into one super efficient truck.
Think of Starship 2.0 as a lab on wheels.
Carbon fiber aerodynamic design allows Starship to slice through the air. Low rolling resistance tyres improve fuel usage. Solar panels reduce draw on the engine. Predictive cruise control analyses the road ahead to control vehicle velocity. A lightweight, optimised drivetrain configuration ensures maximum efficiency. And at the heart of Starship, Shell's latest and most advanced lubricant. Shell's Rotella T6 is delivering remarkable results to improve efficiency. Today, Starship is taking a 400-mile test run, carrying 11.25 tons of cargo.
This replicates real-world operating conditions encountered by Class 8 trucks day in and day out.
To assess Starship in these real-world scenarios, the metric of Freight Tonne Efficiency is being used. Freight Tonne Efficiency takes into account the amount of cargo being transported on each journey. It's calculated by multiplying the load carried, measured in tonnes, by the fuel used, measured in miles per gallon.
It forces you to think much harder about how fuel is being used and, critically, where it's being wasted.
Mike Roth from the North American Council for Freight Efficiency has been brought in to capture data and independently verify results.
We're fitting Starship with high-precision telematics that will give us a live readout during the test.
The tests are being run out of WLA Trucking in North Carolina, Starship's home base. Joining the team today via link from the UK is Bob Mannering, lubricants expert and the lead technologist behind Starship.
The entire Shell Starship project is about energy efficiency in transport, and we're trying to drive the fuel consumption down, the CO2 emissions down, and drive that cargo transporting efficiency upwards as high as we possibly can.
The team found that one of the most effective ways to maximise efficiency is through advanced aerodynamic design. By mimicking the shape of an aircraft, Starship can cut through the air with reduced drag. At cruising speeds, automatic panels extend, sealing the gap between the tractor and the trailer, ensuring smooth airflow as it passes along the body. Side skirts minimise air from passing under the vehicle. And at the rear, a boat tail allows air to exit the trailer with minimal turbulence.
A typical American truck has a drag coefficient in the region of 0.6. Our truck has more than half that, down to 0.25. That's an exceptionally good value. In fact, it's better than most road cars.
In the engine, Starship is running a brand new synthetic lubricant, Shell's Rotella T6 5W30. As the world's leading supplier of lubricants, it's an area Shell has decades of research and development to draw on.
And with that comes a huge amount of expertise and know-how, all of which is being brought to bear on the development of Shell Rotella T6.
Shell scientists developed Triple Protection Plus technology, an advanced formulation that uses a synthetic reduced viscosity base oil to improve efficiency and reduce emissions. In extensive bench and road testing, T6 delivers gains of over 2%.
Many of the freight fleets in America operate a huge number of trucks, so 2% of their fuel bill also translates into a very, very large financial saving. And then in terms of the environment, that equates to a very large impact on CO2 emissions as well.
Back at Command Control, Starship is delivering some encouraging data. Science and technology are producing important gains. But one area that often gets overlooked and is key to achieving good freight ton efficiency is the weight of the truck itself. The lighter the truck, the more cargo can be carried for the same amount of fuel, resulting in better economy and less CO2 emitted.
When we were designing Starship 2.0, we knew reducing our tractor's base weight would be key. So we specified Navistar's LT chassis, Cummins' 2020 X15 next generation engine, and Eaton's Endurance transmission. This integrated pairing reduced our tractor weight by almost half a ton.
The research being done to improve freight ton efficiency has never been more important. Changes in legislation and the Paris Agreement mean that the transport sector must reduce emissions by over 80% in the coming years. After 6 hours and 400 miles, Starship returns to base.
3 years of planning, thousands of hours of R&D, all come down to this moment.
And the results are breathtaking. A freight ton efficiency almost 3 times the US national average for Class 8 trucks, delivering 210 ton miles per gallon. But how good could Starship be if it maximised how much cargo it was carrying? To answer that question, the team devised an ultimate challenge: a coast-to-coast test run. San Diego, California to Jacksonville, Florida. A mammoth 2,315-mile journey, hauling 23.5 tons.
The results we've obtained on the coast-to-coast run are truly staggering. We've ended up with a freight ton efficiency which is 3.5 times higher than that of the current US average.
If this approach was applied across the entire US trucking fleet, CO2 emissions could be reduced by an impressive 71%. The consequences of that, as the world strives towards net zero, would have a huge impact on the environment.
I've spent my whole career working on lowering emissions in road transport. And what Shell has done here is put together a vehicle that will help be the example for a lot of truckers to save fuel and lower emissions.